All right, so I'm going to go over 2 and 3. The others are above 70%. So let's see what number 2 is. Assume the two lines are parallel. We have angle 2 and 8. All right, so let's see. Do we agree that that's the transversal? All right, transversal is the line that's intersecting more than one line. So that's my transversal. So is 2 and 8 on the same side of the transversal? Yeah, they're both on the right-hand side. They're also both exterior angles. I like to think of like two horizontal lines like a hamburger. The meat of the hamburger is the inside and the buns are the outside. So the 2 and the 8 are on the outside. They're not being like forced in by the lines. So these are called same side exterior angles. All right? All right, so we've got same side exterior angles. And same side is supplementary. What does supplementary mean? They equal 180. So angle 2 plus angle 8 equals 180. So let's see what we're working with here. We've got 3x plus 16. And I'm going to add that to 5x minus 20. Set that equal to 180. So if we combine our like terms, we've got 3 and 5. That's going to make 8x. And 16 and negative 20 is going to make negative 4. Everybody okay with what I did there? Combining like terms? All right, I'm going to add the 4. And that's going to get me a 184. And then I'm going to divide by 8. So 8 goes into 23. All right, so x is 23, but the question doesn't say what's x. The question says what's the measure of angle 2. So what I'm going to do now is I'm going to take the equation for angle 2. And I'm going to plug 23 into that equation. So what I'm looking to do is 3 times 23 plus 16. Same side angles are supplementary. The other thing we talked about yesterday is, if that's confusing you, think about angle 2 itself. Angle 2 is a really little angle. It's definitely less than 90 degrees. Would you agree? If I were to take a protractor to that, it's definitely less than 90 degrees. Whereas when I look at angle 8, that's like a very big angle. So our options in parallel lines is we're either going to do the two equations equal to each other, like angle 2 equals angle 8, or we're going to do angle 2 plus angle 8 equals 180, right? So we're either going to add them up and set them equal to 180 or set them equal to each other. If they look different, here one is acute and one is obtuse. If they look different, set them equal to 180. If they look about the same, set them equal to each other.
They're like different sides.
Yes, alternate interior and alternate exterior equal each other, yes. All right, let's look at, I think the next one was number 3, but let me go back and make sure. It looks like a lot of you that had that wrong, though, had 23. I see a 23 here. So if you solved for x, and you just stopped. Just make sure you read the question. If it says solve for angle 2, especially on multiple choice, 23 is going to be one of the options. It's called a distractor. So just make sure you're answering the question. All right, the next one is number 3. Looks like it's another parallel line relationship, and we're looking at angle 1 and 8. Yeah, so this kind of goes with your question. These ones are on different sides. These are called alternate exterior. They're on different sides of the transversal. Now let's look at angles 1 and 8. Angle 1 is a big angle. It's definitely more than 90 degrees. And angle 8 is a big angle. It's definitely more than 90 degrees. If they're both obtuse, then set them equal to each other. Okay? Mathematically, the reason that I'm setting them equal to each other is they are called alternate exterior angles. And alternate exterior angles are equal. So angle 1 is equal to angle 8. In terms of the solving here, that means that 10x plus 2 is equal to 15x minus 78. So I can subtract the 10x. That's going to get me a 5x here. And then I'm going to add the 78. I'm just doing this all in one step because I don't have a lot of space. And that's going to get me an 80 here. Alright, so we get 16. Now the question doesn't say solve for x, does it? It says solve for the measure of angle 1. So I'm going to have to plug that into angle 1. Alright, so to find the measure of angle 1, I'm going to take the angle 1 equation. 10x plus 2. And I'm going to do 10 times 16 plus 2. So this is 162 degrees. Alright, so just review those two were less than 50%. So I felt like we needed to go over them before we move on to that. Alright, what you need for today's class is your final review guide packet. Today we're going to review one of our post-midterm topics, meaning that in terms of your final exam, this is going to be on there a lot more than geometry and linear programming. So you already took an assessment on those. These were not on an assessment, okay? Another thing that you might want to take out for today if you lost it, it is not the end of the world. I don't have any right now, but I will make sure that I have extras on the day of the final. So you might just kind of have to look off somebody else's. Alright, so before we jump into simplifying roots, I want to go over the basic exponent properties with you. I'm going to do today's review a little bit differently. I'm going to review a concept and then have you practice. Review a concept and have you practice. Yesterday I did a lot of talking and then had you practice. I feel like when I do that, you're exhausted from listening to me by the end of the class and then you don't do the practice. So hopefully a little back and forth might entice you to do the practice more, especially because this is really on the final. This topic, okay? So, multiplication property. We are going to multiply coefficients. This is on page 5. Keep the base and add the exponents. The key here is the adding the exponents part, right? If you're multiplying in exponents, you're actually adding. Division property, we are going to divide / simplify the coefficients. We are going to keep the base. And multiplication is opposite of division, addition is opposite of subtraction. So we are going to subtract the exponents. And then the last property is the power property. The power property, we are going to raise the coefficient, keep the base, and we already added, we already subtracted, so multiplication is left. And we're going to multiply the exponents. The first thing you got to do is you got to figure out, well, which of these three rules is happening, right? It's not going to be use the multiplication property to solve this problem. You have to identify that it's a multiplication problem. So, which numbers on here are the multiplication problems? 1 is definitely a multiplication problem. I've got 2 sets of parentheses. Any other ones?
4.
And 4. There's a ton. So multiplication, you might see it in 2 different ways. Parenthesis next to parenthesis, or you might see like some sort of multiplication symbol in the middle. Division's pretty simple, right? It's when you're going to see this complicated looking fraction. And then power is going to be parentheses, just like multiplication is, but the difference between power and multiplication is with power, there's an exponent on the outside. With multiplication, the exponents are on the inside. So these are my power problems. All right, so I'm going to apply each rule. I'm going to do the multiplication ones first, so I'm just going to go down. All right, so multiplication property says I multiply the coefficients. So I'm going to do 5 times negative 2. That's negative 10. I'm going to keep the base the same. And I'm going to add the exponents. I can't tell what that exponent is. Is it a 1/5?
Yeah.
Okay, it's a 1/5 and a 4/3. So I'm going to do 1/5 plus 4/3. You do not call that 5/8. That is not the way fractions work, okay? Use your calculator to do the math. You could find common denominators and do it yourself, but there's just no need to do that, right? It's so much faster to just type that into your calculator. So I'm just going to go to my calculator and I'm going to do, you could do it like this. You could do the alpha y equals tool. So we can do it like that. Or I don't even think you need parentheses when you do this. Like you can do that, right? Either way, 23/15 when I get that. So my answer then is negative 10x to the 23/15. Now, I'm not going to do this for every problem, but on a multiple choice exam, if you know how to use your calculator, you can get your way through most of the exam, okay? So, if this were a multiple choice question, you would type this in Y1 the exact way it looks, okay? So, what that means is I have in Y1 parenthesis 5x to the 1 divided by 5, close parenthesis, negative 2, right? X to the 4/3. The question's in Y1. And then in Y2, I would type whatever the answer to A is. And I check it in the table. B, check it in the table. The right answer will match. What did we get? 23/15? The right answer will match all of the values in the table. So if you forget the rules and it's multiple choice, you have this strategy. So hypothetically, if these didn't match, I would go back to y equals, clear out Y2, and then type the B answer in. And I could do that for all of them. All right? I'm not going to do that for all of these problems. I just wanted to show you that that is a test-taking strategy that you could use. All right? Now, what's different about number 4? Because that's multiplication too. Right, meaning it's not a coefficient, right? The base, he said, has an exponent. 18 is not a coefficient. If it's got an exponent on it, it's not a coefficient. So I'm not going to do 18 times 18. I'm going to keep 18 the same. And I'm going to do 1/4 plus 1/4. I'm going to keep x the same. And I'm going to do 13/2 plus, is that a negative 3? Okay? So the difference between 1 and 4 is that 1 has coefficients. It has numbers in front that don't have their own exponents. 4 doesn't have any coefficients. The 18 is considered a base. So I'm gonna add 1/4 plus 1/4. And I'll type that in the calculator, 1/4 plus 1/4, which is 1/2. But you don't have to know that, you can type it in the calculator. So I end up with 18 to the power of 1/2. What I'm gonna do is, I'm gonna check if that simplifies. If that became a whole number, I would write the whole number, but it doesn't. So I'm just gonna leave it as 18 to the 1/2. And what do we get when we do 13 over 2 plus negative 3? Thank you. 7 over 2. So we'll have x to the 7 over 2. Alright, so that's what the multiplication property looks like. Multiply the numbers in front, but if the numbers in front have an exponent, then they're not coefficients. So keep the base the same, add the exponents. With subtraction, we're going to divide / simplify the coefficients. So I'm going to do 20 divided by 5. Alright, in this case, I don't have to simplify that because it works out nicely. 20 divided by 5 is 4. I'm going to keep the base the same, and I'm going to subtract the exponent. So I'm going to do 10/3 minus 3/4. You do not have to know how to do that. You can type it in your calculator. 10/3 minus 3/4. 31/12. Now what's different about number 5 is when I go to do the division of 9 divided by 36, it doesn't work out nicely. Because you got to do the top number divided by the bottom number. So that's where the divide / simplify comes in. If this isn't a nice number, you're going to math enter it. So I get 1/4. I'm going to keep the base. Now what's bigger? 9 9/5? Or 1/4? 9/5 is bigger than 1, right? So I'm going to keep the x up here. And I'm going to do 9/5 minus 1/4. I'm subtracting the exponents. You do not need to write the 1 that I have here. 1 is a placeholder number if there's other things that are there. Right, so with division, we're dividing, and when the division works out nicely, then we can just divide. But if the division doesn't work out nicely, we have to simplify. That's where this 1/4 comes from. And then we're subtracting the fractions, which the calculator will do for us. So you just type it in your calculator. All right, last one, power property. So I'm going to raise the coefficient. Here's what that means. I'm going to take that 243, and instead of multiplying it by 1/5, I'm going to raise it to the power of 1/5. So it'll be like 243 and then exponent of 1/5. I'm going to keep the base the same. And then I'm going to do 25 times 1/5. You can just type that in your calculator. It's 5. What I have to do here is I have to check this in the calculator too. I'm going to type that in the calculator and see if it's a whole number. So 243 to the 1/5. Some of you have to use parentheses around the 1/5. If you have a calculator that doesn't raise the exponent, see how my exponent gets like smaller? If your calculator keeps it down, you have to put it in parentheses. So it would be like parentheses 1 divided by 5. That works out nicely to a 3. So I'm going to change this answer to 3x to the 5th. All right, so 128 will be raised to the power of 1/6. And then I am multiplying the exponents. 4 times 1/6. Math, enter, enter. We'll call that 2/3. You want to type that in the calculator. 128 to the 1/6. If it's a decimal, then leave it alone. There's nothing you can do to it, and you just leave the answer like that. The fraction part was new this semester. However, you have a calculator, and the calculator will do the fraction part. You just need to know the rules. Alright, so your practice for this section is on the final review guide, which is at the end of your packet. So page 18, number 13. I'm gonna go 6 minutes, a minute a problem, and then I'll like reevaluate. I have 10. Just show me more than that. So at 8:17, I might post the answers, but see what you can do on this. You've got similar problems. They're mixed up though, so you have to identify, is it multiplication, division, or power, and then apply the rule. Take a moment, check out what you have. $64 to the 1/3 did become a whole number. However, 128 to the 1/2 didn't, so I just left that as is. It's not 128 times 1/2, it's the power of 1/2. Remember, for these types of questions, you have this strategy of using the Y1 and Y2 tool of your calculator to guess and check your answers if you're struggling. So like if you got a lot of those wrong, I recommend using your calculator when you're on your test and just double checking. Type the question in Y1 and what you think the answer is in Y2. The table should match. Does anybody have questions on any of those?
So for that, for B,
Yep. I did 5/3 minus 3/2. About 1/6. Alright, maybe you just type something in wrong. Alright, we are going to head back to page 5 where we just left off. And this section is about writing things in radical form. Radical form means that all of the answers for these 6 problems will end with a root. They should have a root with them. So what you need to remember from this section, that it's x to the inside over outside. If you have something in exponent form that has a fraction, if it's got a fraction, it can be written as a root. I'm just using O and I for inside and outside there, but the outside number is the denominator of the fraction. And the inside number is the exponent, the numerator of the fraction. If you have something that has an exponent and the exponent is a fraction, then you can write it in root form. The base, which is below the exponent, stays inside. The numerator stays inside. And the denominator goes in this little nook part. It's called the index. This becomes a 6th root. If the inside number is less than the outside number, you're done the problem. You don't have to do anything else. Now, for number 8, that negative 14 that's in the front is not touching the fraction. The fraction only belongs to the x. So when I write the root, the base is x. It's not 14x. The 14 is called a coefficient. It's not a base. The base is what goes inside. The inside number would be the numerator, and the outside number would go as the denominator. Now what that means for the negative 14 is it's just going to go to the front of the problem and get carried down as we go. Now, to simplify a root that is a variable, you need to think about what's called multiples of, and you want to focus on the outside number, multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. 33 is too much. Like, I'm going to stop when I exceed my number. The multiple you want to pick is the one just below it. So I'm going to use the 30. And I'm going to split this up. The first one will be a 30. What does the second one have to be? It's got to be a 2. I still need to make 32. Right? So that second number is going to be a 2. Now this is just a negative 14. You guys remember this? Is it starting to come back? Inside divided by outside. 30 divided by 3 is a perfect 10. You just can't forget that there's an x on that. And when the inside number is smaller than the outside number, you're done. And that negative 14 is just coming along. All right, now in this next one, I've got 2 fractions, which means I've got 2 roots. I'm going to have a root for the 2 and a root for the x. Both of them have fractions, so both of them get roots. The top is the inside number, the bottom is the outside number. Inside over outside. Now what I'm going to do is I'm going to type 2 to the 5th in the calculator. Figure out what that is. So 2 to the 5th is 32. So this is the 4th root of 32. Now in terms of the variables, we know how to simplify that one. We're going to look at multiples of 4. 4, 8, 12, 16, 20, 24, 28, 32 is too much. So I'm going to pick 28. So what's this next one have to be? It's got to be 3. 28 plus 3 is 31. So it's inside number 28 divided by outside number 4. That's 7, but I can't forget that there's an x on that. When the inside number is smaller than the outside number, we're done. So that takes care of the variable part. Now, in terms of this part, we're going to go to the y equals screen, and we're going to do 32 divided by x. This is where your blue sheet comes in if you have it. What you're looking for is the 4th column, the x to the 4th column, because this is a 4th root. I'm looking for one of the perfect 4s to show up here. Do you see one? Those of you with the sheet? 16? So next to 16 is a 2. So I'm going to do the 4th root of 16 and the 4th root of 2. Just be careful, the 4th root of 16 is not 4. You are not doing inside divided by outside. There are 2 ways to get this number. The first way involves your calculator. You can hit math 5. It's going to give you something that looks like this, and you can type it in. The other way to do it is go to this slit, put your finger on the 16, and go over x equals 2. okay? It's not 4. You're not doing inside divided by outside. So my final answer for this one, I don't have a lot of space, is the 4th root of 16 is 2. And then I'm going to keep the 4th root of 2. And then I've got x to the 7th. I'm going to put that in the front. And I'm going to put x to the 3rd in here. 2x to the 7th, 4th root of 2x to the 3rd. This was 2. Are you okay with that one so far? I'm not going to do the whole bottom row here, but I'll pick. Alright, so these are already in radical form. I'm going to keep them in radical form. It says right in radical form. But I'm going to see if I can simplify this. So, I'm just going to split this up. For this number, the first thing I'll do is I'll math 5 it. So it's the 7th root of 2187. If it becomes a whole number, then you want to change it. And for this one, I'll do inside divided by outside. And if it becomes a whole number, which it does, I just can't forget that there's an x on that. Those were both perfect, so I just get 3x to the 6th. Again, I'm going to split this one up. I've got the 5th root and the 5th root of x to the 29th. So I'm going to math 5 this. It's different. What is it?
19.
Just the 3, this
No,
part?
no, like
Oh, it might be 19 and I just can't see it. Thank you. Is that good now? Alright, so math 5, I'm going to do 3072. When you get a decimal for this, go to the y equals screen. And what I'm looking for here is a perfect 5. So if you have your list, you're looking in the 5 column. Is 1024 a perfect 5? Yeah. It is. All right, so I'm going to use 1024, 1024, and then the number next to it. And the number next to it was 3. So now that I have that, I can math 5 each of them. And you'll see that one of them works out nicely and the other doesn't. So I'm going to leave the 3 inside, but I'm going to change the 1024 to a 4. In terms of this one, I'm going to think of multiples of 5. 5, 10, 15, 20 is too much. So I'll do 15, and then by default, this is going to have to be a 4. They have to add to 19. Inside 15 divided by outside 5 is 3. Can't forget there's an x on that. Inside 4 divided by outside 5 is a decimal. When the inside is smaller than the outside, you're done. And I'm just going to rearrange my answer. 4x to the 3rd, 5th root of 3x to the 4th. So the root numbers go together and the inside numbers go together. Now this is going to be more of an open-ended type of question. But you can still check your work. If you type that in Y1 and that in Y2 and check your tables should match if you do it right. They will not match if you do it wrong. That's not gonna help you get the right answer, but it's at least gonna help you go back and fix it. You okay with that? Alright, so we're gonna finish here with some practice, and I'll post the answers at the end of class here. But the practice is page 18, number 14. And then just before class is over, we've got 8 minutes. So in like 6 minutes, I'll post the answers, see where you got. But all of these should end up in radical form. So you're keeping the bottom 3 in roots, you're just simplifying the roots. The top ones, though, you have to get them to radical form first.